we'll talk about cyanide toxicity. Toxicity caused by cyanide, a very famous or rather infamous poison for committing suicide, but not for homicide because of its bitter almond smell and taste, etc. It is not given for homicide, but several myths are associated with it that cyanide causing instantaneous death. Nazi gas chambers during World War II, they use cyanide as a poison. Even Americans also, we talk America as hallmark of perfection. Let's continue with that. But with the incorrigible criminals, America also, this cyanide has been reported to be used at several places. So what cyanide does? Cyanide ATP का generation कम कर देता है, and ATP, as all of you know, it is currency of free energy in the body. So how cyanide decreases production of ATP, energy depletion, and death, of course, would be the consequence. No ATP, no life. So, इलेक्ट्रॉन ट्रांसपोर्ट चेन, इसको थोड़ा सा बैकग्राउंड हमें बिल्ड करना जरूरी है. TCA cycle is the final catabolic pathway of all nutrients, carbohydrates, fats, proteins, everything. And TCA is the final culminating pathway, and important coenzymes are generated in this pathway, NADH and FADH2. These are reduced coenzyme, means they contain reducing equivalents. This by dot I have represented them. So these reducing equivalents, these electrons, in fact, they are funneled into electron transport chain, and as they move down the electron transport chain, these electrons, they enter at various places, and as they move down the electron transport chain in a stepwise fashion, they release free energy. And finally, electrons, they emerge from the electron transport chain. Now, please see, when the electrons entered the electron transport chain, they were very high in energy content. Energy rich electrons, that's what we call them. And when they are emerging, so that time they have lost most of their energy. So, where has this energy of the electrons gone? This energy is trapped in form of ATP. Something like, you must have seen hydroelectric projects, water falling from great heights down below. So, uski energy, potential energy from the height, it is gone as it falls down, and it is trapped in form of electricity. And what drives fall of the electron? It is gravity. But here what drives movement of electrons? It is redox potential. Read about it. So redox potential along from negative to positive, electrons will fall. So I am repeating, as the electrons move down their electron with their gradient, redox gradient, they release energy which is trapped in form of ATP. Now, why I talked in so much of detail? I just wanted to emphasize that electrons, they travel in small steps, and energy is released in the packets of useful energy, packets of useful size, you can say them. So there are several complexes. There is complex 1, 2, 3, 4. Complex 4 lies at the end. Cytochrome oxidase, copper, iron are important parts of this complex. Now, the most important part of this lecture, cyanide is inhibitor of complex 4 of the electron transport chain. So, अगर electron transport chain inhibit हो गई, and that also at the final stage, what will happen? Flow of electrons along the electron transport chain will be hampered, and the whole process, ATP generation, will fall down. And as we said, ATP is currency of energy in the body. We need ATP all the time. So no ATP, no life. So that is the reason cyanide is such a toxic poison. तो इसको हम कैसे कर सकते हैं, ट्रीट कर सकते हैं क्या साइनाइड को? यस, इट इज पॉसिबल बिकॉज एज वी सेड साइनाइड बाइंड्स टू साइटोक्रोम ऑक्सीडेज. This is a heme containing enzyme, and this contains, of course, heme contains iron in the center. So cyanide binds with the ferric form of heme. This is where cyanide is binding. इसका ट्रीटमेंट की क्या मॉडलिटी हो सकती है? यू रिमूव आयरन साइनाइड फ्रॉम द फेरिक आयरन. How we can remove cyanide? By introducing something which has got higher affinity for cyanide than the heme iron here, and that something is sodium nitrite or amyl nitrite. These two agents, they cause, let me say here, they cause production of methemoglobin from hemoglobin. क्या फर्क है? Hemoglobin contains iron in the ferrous state. Methemoglobin, it contains iron in the ferric state. So the heme iron of methemoglobin is in the ferric state, and it has got higher affinity for cyanide than the heme iron of cytochrome oxidase. So it attracts cyanide towards itself, resulting in its dissociation from the cytochrome heme. So you dissociate it, and that is an effective modality. So these two reagents, sodium nitrite, amyl nitrite, one of them is injectable, another is given by inhalation. Find out why they are.